Okay, so we've all of a sudden established why you didn't think there was enough information and I did. It's because of something that I regarded as implicit that you didn't. So, okay? So naturally, you know, there's a little discrepancy there. Okay? So, you know, what I said, you know, I wrote down the information, okay? That it reaches a maximum height of 50 meters after 4 seconds. So x of 4 is 50 meters. Now we don't have x here, but we had x here, and we know that x is just an antiderivative of v. And there's where the question came. Okay, we'll see that in a minute. And then the velocity at 4 seconds is 0. You got to be able to read and understand how projectiles work. This is the maximum height. That's where the velocity is 0. So velocity at this time is also 0. So you got to draw that conclusion. Okay, well now, 50 meters is the maximum height. Then gives you both of these if you know that one or another of them occurs at 4 seconds. Okay? So now what do we have? We've got two conditions here. What unknowns do we have in the equation? We don't know gamma, we don't know A. G is the universal, well, not a universal constant, but it's the acceleration of gravity. And again, that's implicit. If you want to do this on Mars, go ahead. Okay?
Or in the upper atmosphere.
Yeah, yeah. Yeah, you reduce G by a little bit, but as long as you're in the atmosphere, it ain't changing much. You know, maybe 1%. Okay? So anyhow, we've got all this. So we go ahead and put our initial conditions in and see just where your question came about. Okay, so first of all, x of t is an antiderivative of that gamma look not having any luck here. Okay. Still doesn't look much like a gamma. Now it looks like a psi. I don't know. We're going to accept that as a gamma. Okay? Never know quite which part of the chalk is going to write, but after all these years, I should be better at it than I am. Okay, so anyhow, our antiderivative is very easy. mg over gamma times t minus m over gamma a e to the negative gamma over m times t plus an integration constant that I'll call c. And there's where you had a little uncertainty, okay? And when I stated the problem, I said it shot into the air, reaches maximum height. I didn't say at what position it was shot into the air. And if you're going to shoot something into the air, you're probably going to shoot from above the ground. So when you say it rises to 50 meters, you got to know how far above the ground you were, right? And you've shot things, you know, you kill things all the time.
It's just a hobby of mine.
Huh?
Just a hobby of mine.
Yeah, you know.
See what I can kill.
So there is a bit of interpretation there. The default assumption would be that the height is measured relative to where you shot, since there's no further information. Okay? So assuming implicitly that height is measured relative to the position from which the shot was fired. You know, I say C equals 0, and that's wrong. Okay? C equals M over gamma times A, right? If this is 0, but this is 1. Okay? So you got the negative M over gamma A plus C equals 0. C has to equal M over gamma times A. Okay? So now we got a function for X, and we've of course got our function for V. So we can write down our two simultaneous equations so that we have mg over gamma times 4 seconds, right? Kind of wrap this equation, minus m over gamma a e to the negative gamma over m times 4 seconds plus m over gamma a equals 0. Now this might be a little tricky to solve because you got one of your unknowns up here. Okay? So, you know, let's see what comes out of this, because we might not be able to get a closed form solution. Might have to approximate a solution, but maybe not. So let's write out what happens for V. Okay, V of 4 equals 0, so we have mg over gamma plus ae to the negative gamma over m times 4 seconds, and that's going to be very helpful, equals 0, right?
Yeah, that one's gonna, the top one's going to equal 50 instead of 0.
Yeah, V of 4 is 50. I guess I have to write that 5 a little more clearly. Okay. Okay? And that is going to help, because now we're going to have an expression for AE to the negative gamma over m times 4 seconds, which is just mg over gamma, right? Okay?
Okay, yeah.
Negative mg over gamma.
So you can solve for A and then, yeah.
Okay? So, I don't really want to take time, because we're second to last day of class, to solve the simultaneous equation, but you see the way forward, and I think I do too. I haven't got the whole solution in my head. The only hang up I see, and I don't really like it, you're going to have a m squared over gamma squared here, so you're maybe going to have a quadratic in gamma. Okay, and you still got an a here, and that might complicate things a little. Okay, so it still might be a little difficult. I have to write it out. My head isn't working well enough to visualize it right now. But I'm kind of visualizing a potential pitfall there. But at least you have two simultaneous equations, and if you can't get an exact solution, you can at least approximate it. Okay?